All right, so we're going to get through this as, not fast, but as at a generous pace as we can. So your warm-up, you should have graphed y equals x squared, looks like that, and you should have drawn a little graph for me, okay? Everyone's got that with your objective. Life's good. And now, I want y'all listening, so I don't want y'all listening to other stuff. So if y'all can make sure you're listening, and also make sure that you're awake and not in the Kirby's Dreamland, right? So, let's get started here. All right, everyone has 1.7? Okay, we're talking about a fictional situation in which, both of them, in which Miss Hernandez, one second. Dang it. I'm already having difficulties, right? Yeah. See, for some reason my scroll bar was on the wrong side, which is annoying, so I'm just going to restart it. All right. So this will take a good, way too long, whole minute to load. While we're doing that, if you read it, on the engaged section, it says Miss Hernandez wants to construct a rectangular sandbox for her niece and nephew. She has how many feet of lumber? 36, right? So think about one long, plank of wood. What are some possible dimensions Miss Hernandez could use? Now y'all tell me, what dimensions of a rectangle could there be to make 36 feet? What and what will the dimensions be? Numbers, please. Two numbers, not one number. 9 by 9, okay? So will a 9 by 9 give you 36 all the way around? Actually, let me do this down here. 9, 9, 9, 9. So 9 times 4 is 36. That's good. What's another one? 6 by 6 is 36. No. Well, I mean, sorry, 6 by 6 means 6 times 4, which is 24, not 36. My bad. Because we're thinking perimeter. The perimeter has to be 36. So give me two numbers. Okay, 18 and what? Okay, I need two numbers that are going to... 18 and what? I need two numbers. Okay, I'm done listening to you. Thank you. So, what? 12 by 6? So 12 and 6, and the other side will be 12 and 6. So does that add up to 36? 12 plus 6 is 18. 12 plus 6 is 18. 18 and 18 is 36, okay? Now, what could another one be? What do y'all think? $18 by what? No. 15 and 3? 15 and 3. 15 and 3. So yeah, 36. Good. Now, here's the deal. There's an easy way to figure out all the possible options. You know, all the way around has to be 36. So the two side lengths have to be half of that. What's half of 36? 18. So basically, the length and the width have to add up to 18. So 9 and 9 is 18. 12 and 6 is 18. 15 and 3 is 18, right? See the pattern? So now you can give me another one. What's another one that we haven't done? Two lengths, length and width that add up to 18. 10 and 8, okay? 10 plus 8, 10 plus 8, altogether is going to be 36, okay? Now, just so y'all know, in this situation, she's going to be looking to maximize the area of her sandbox. So, if you flip it over, we're going to start filling in a table. So flip it over, please. Okay. Flip it over, please. Now, what we're going to do on this table is we're going to give all the possible dimensions that are going to give us 36 for the perimeter. Now, so perimeter is what I just said, right? That says area. Now, real quick, we just said, what was our little trick? The width and the length have to add up to what? They have to add up, oh my gosh. Okay. Right there. Okay. let's do this. There we go. It's just not really, what do you call it, calibrated. So, it's all right, though. All right, so these two have to add up to what? 18. So what we're going to do is we're going to literally put every single possibility. So if the width is 3, the length has to be 15. And then using the width and the length, you can give me the area. Now, what do you do with these two numbers to get area? Some of y'all were in my geometry class, and you better know this, because you weren't sleeping. Okay, length and width, what do we do? Multiply. Length times width is area, right? Cool. Now, on the width, we're going to do every single option. So no one's on their phone in the corner of the room, right? So let's write this down. 3, 4, 5, 6, all the way down. And in fact, go ahead and go one past that and put 17, just cause. Now, if the width is 4 and it has to add up to 18, what's the length going to be on the second one? 4 and 14 make 18, right? What about 5 and what make 18? Okay, 13. And then 6 and 12. So what's happening each time on the length? As this one goes up, the length goes down. So that's easy to do, right? Fill that all the way down. Don't laugh at me. All right, now, on the last one, here's where you got to do some math. How do I find the areas on all these? Multiply. So, again, the faster you answer me, the faster we're done. 4 times 14, what do we get? 56. 5 times 13. Okay, 6 times 12. 72. 7 times 11. 77. 8 times 10. 80. 9 times 9. Bet. 10 times 8. Now hold up. Do you see how now it's just kind of flipped around from what we had above it? 8. What's the next one? 11 times 7. 77. 12 times 6. 72. 12 times 5. 4 times 4. You writing this down too over there? Oh, really? 15 times 3. Okay, 16 times 2. And it's 17 times 1. All right. Now, I wonder what kind of function this is, okay? It might be kind of obvious from the unit that we're in. On the front, it tells you the title. But let's think about this. Number one, what do you think the scatter plot would look like? Before we make a scatter plot, what do you think it would look like? If it goes up in area and then down. Would it look like a what? Okay, so it kind of looked like that quadratic function from the warm-up, except it would be kind of flipped around, right? Going up, then going down, instead of going down and then going up. Okay, so let's make a scatter plot. So we're going to take this information into that little grid over here, but the only way you're going to make it fit is if you follow what I'm telling you right now, okay? Horizontally, the x values, put x next to width. This is my x. And your y is your area. Put a y next to the area. You're kind of ignoring the middle column, okay? The reason why, because it says area versus width. So ignore the length, right? So for the x, I'm going to use my width, which goes all the way up to 16, right? I drew an extra 17, but it goes up to 16. So starting at 0, it's just 1, 2, 3, all the way up to 16, okay? So the x is just 1, but the y has to go all the way up to 81, right? So I can't count by 1, I'll only get up to 16. So my suggestion is to count by 5. That'll get you up to 80, 81 will be like just above it, okay? So let's count by 5s here. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 80. All right. Now, can you graph this? Let's do it. Scatter plot. So 3 will give me an area of 45. So everybody, find 3 on the x, find 45 on the y, give it a little plot. Everyone's plotting 3, 45. Then 4 gives me 56. So at 4, I'm going to find 55 and go just a little bit above it. All right, and I want you to keep doing the scatter plot for me. If you have trouble plotting it, let me know. $5.65. Ooh. Let's see it. I see people waiting on me. I'm waiting on you. $6.72. A little bit above 70. $7.77 above 75. $8.80 right there at the top. $9.81 is above, right above that. And then the numbers kind of go back the same way. We're not doing checkers. We're not sleeping, right? Look at all that work. You could have been plotting 3, 35, whatever it is. 345. All right. So then it goes 1080, and then it keeps following the same pattern going down. 16 is at 32. And 17 out here is at 17. Just so you know, 2 is also at 32, and then 1 is at 17. So that's 117. That's 17. And then up here at the top, this is 981. Excuse you. Now, number 3. Based on the graph, now that you see that graph, what kind of function is that? What do you think? Good. If you could figure it out from our 1.7 notes title, yeah, it's quadratic, right? So, wow, that's weird. All right, well, anyway, it's quadratic. Number 3, the function is quadratic because it makes a parabola. Parabola. Looks like a U or an upside down U. Parabola. Parabola. Okay. Number 4. Now, they want us to prove that the table is quadratic. Now, I know you can see it, and I know you know it, but remind me, we did this on the last assignment. How do I tell a table is quadratic? What do I do on the side here? Okay. And it says it down here. We do it by finding the finite differences. Meaning, difference means what? Subtraction. So, 56, and let's do this fast. 56 minus 45 is what? 11. 65 minus 56 is what? 72 minus 65 is? Okay, 77 minus 2. Okay, do you see a pattern happening here? Going down by 2. What's 80 minus 81? Oh, by the way, that's a 1 right there. It's a funny 1 now. All right, now 80 minus 81. All right, I'll fix it. All right, that's a 1. Now 80 minus 81 is actually negative 1. 80 minus 81, okay? And then 77 minus 80 is negative 3. And you get the pattern. It keeps going down by 2, okay? So is it linear if these are all different? No, right? If the first difference is not the same, it's not linear. So is it linear? No, not linear. What do you say? Okay, now quadratic. Let's see if it's quadratic, right? Now, how do I tell if it's quadratic? What do I have to do to these numbers? Find the second difference. No, we're just going to first see if this is the same. So 9 minus 11, negative 2. 7 minus 9, negative 2. 5 minus 7, negative 2. What do you think the rest of this is? It actually is negative 2, okay? So is it quadratic? Is it quadratic? Say it. Say it.
Yes, sir.
All right. Original content. No royalties, though. So, all right. So, yes. Why? The second difference is the same. All right. All right. No names. No nothing. So, number 5. Use the patterns in the finite difference to write a function rule. Now, if it says function rule, I'm saying get the equation using what you already know. How do I get the equation from a table? How do I turn this into an equation? Spreadsheets? Menu 4-1. What? 416 is quadratic. No, 6. We know it's quadratic, so it's menu 416, right? 4-1a is exponential. 4-1-6 is quadratic. Oh, 8? Don't be a goofball. All right, so let's do this. Now, go to your calculator. We're only going to put in 3 coordinates here. So we're going to start with the first 3 on our listen spreadsheets when we put x and y, of course. Now, the first 3 on this table are 3, 4, and 5. Let's do that. 3, 4, 5. And my first 3 over here are 56, 65. No, sorry. That's not true. That's not true. It's actually, it's 45, 56, 65. So again, we're doing width and area. Again, quadratic means menu what? 4, 1, 6. So x for x, y for y. And now, remind me, what does this mean? Any number with an e, with a negative big number, okay, that's so small it's 0, okay? So again, if you see something weird, 0, okay? So that means my a is negative 1, so my equation would be y equals negative 1x squared or negative x squared. You don't need the 1. Plus, my b value is 18x. And if you put plus 0, it's not wrong, it's just not necessary. So don't put plus 0, okay? For 6, use the graphing calculator to graph the function rule over the scatterplot. Now, we're not doing it in the calculator, but you can go ahead and just trace this. That's what it would look like in your calculator, okay? And yours will hopefully look prettier than mine, okay? So when you graph it, it's going to go through all those points perfectly because it perfectly had the same second difference every time, okay? All right, what did you notice about the function rule and the scatterplot? They're the same, okay? How do I know that? Well, I know that. Just telling you, okay? Now, we're going to skip 7. We're going to talk about domain and range more soon, okay? But just to tell you, okay, the domain goes from 1 to 17, right? You can't have a side length less than 1. You can't have a side length greater than 17, okay? I know there's like fractions, but we're just going by units here, whole units. So the domain would be between 1 and 17. The range would be between 17 and 81, okay? So we're going to skip over this. We're going to do this more in depth later. Number 8, though, says, what dimensions has the greatest area? You tell me, from this table, which one has the greatest area? So the greatest area is 81, right? It's at the top of that parabola. So the dimensions are 9 by 9. Does that make sense? So you can have dimensions with the same perimeter giving you different areas. The best shape is a square to give you the most area, okay? So it's 9 by 9. Okay, and then number 9, x-intercepts. Now, wait, hold on. We have a song.
When y is 0, what is x? The x-intercept. Yeehaw!
Again? You want to hear it again?
When y is 0, what is x? The x-intercept.
All right. So y'all tell me, can we have an x-intercept? So that means that y can be 0. We can have a 0 length. Have you ever seen a 0 length in your life? Okay, so there's no such thing on a sandbox having one side being 0. Okay? You actually have to have at least one unit of some sort, right? So the answer to number 9, are the x-intercepts of the function included? And the answer is no. They're not included because you can't have a 0. Can't have a 0 length. All right, and after all that, 10 and 11. Okay, we're going to skip 10 and 11 for now, and that'll be it for today. Cool.